Hazır mısınız? Okay. Teşekkürler. Hello everyone. How are you doing? I'm hoping you are doing well. I'm very pleased to be here. I will be talking to you about my experiences in pursuing science, especially basic sciences. So in order for you to appreciate where my experiences are coming from, I need to first tell you a little bit about what I did in my life. I graduated from Middle East Technical University. That was probably at a time when all of you were not born yet, 1973. So I did my bachelor's and master's in Middle East Technical University in Ankara and graduated in electrical engineering. I always wanted to be an academician for personal reasons because I didn't want to be, work for the government or do work for private entities. So I thought academician is a good balance between the two. So I wrote to universities in the United States for PhD. And I got admission from 3 universities. I wrote to only 3 of them: Stanford University, University of Illinois in Urbana-Champaign, and Polytechnic Institute of Brooklyn. This has a different name right now. So I got admission from all of those because my grades were quite good. So then I accidentally, without really knowing what I was doing, I picked Stanford among these 3. I went to Stanford University. At that time, Neil Armstrong had landed on the moon, and space was magical. You know, everybody was interested in space. And so I did my PhD in space science. I was interested in pursuing my interest, even though my whole purpose was to return to Turkey after PhD and to become an academician. And there would have been no jobs in Turkey for a space scientist at the time, and even now, maybe. So, but I did pursue my interest because it was really fascinating. And then what happened was, at the time I finished my PhD, there was a search for a faculty member at Stanford that I applied. And among many applicants from the world, they picked 2, one senior person and one junior person, and I became the junior person. So I suddenly became a faculty member at a place like Stanford, and even though I had gone to the United States with the purpose of returning to this country eventually, I couldn't at that time because Stanford is such a great place to be an academician. So I stayed there for 36 years. That's 36. So that's a lot of years. So I have still lived more of my life in the United States than here. So during those 36 years, I investigated the Earth's ionosphere, atmosphere, and magnetosphere. So I'm a space scientist, but I'm not, for example, an astrophysicist. I'm not interested in other stars, not even the planets, although I did do some work on Jupiter and Saturn. My main interest is the Earth and its environment and space environment. In space, around the Earth, there is, of course, a magnetic field of the planet that dominates the physics of everything in the surrounding region. And there is very high energy particles, electrons, protons, and other ions. And the physics of these are extremely interesting. And these things were science, basic science, with no applications back in the 70s and in the 80s even. But it's a very interesting story because it talks about the importance of basic science, which may have applications 10, 20, 30 years from now. Because a lot of people have the dilemma between basic science and applied science. In fact, R&D is a very interesting word, research and development. And in this country, for example, in Turkey, people talk about R&D, but really what they are doing is D. There's very few institutions that do R and D. Most institutions are simply doing development of products, for example, and they are, talking about it as if they are doing R&D. Because it really is very interesting that the difference between R&D is very interesting. Because we are talking about basic science here. It says basic science and requirements of academic use, academic life, and so I want to talk about basic science. In any case, so at Stanford, I had the opportunity to work with 60 PhD students. I graduated 60 PhD students. 15 of these are professors right now at the prestigious universities in the United States and Europe, and 45 of them are employed at some of the best companies in the world, like Lockheed, Rockwell Collins, Raytheon, Boeing, and so on. So it's very interesting because these were very bright students at Stanford. Stanford PhD program admits only the brightest. And so my interactions with these students were very interesting for me. And at Stanford and at other universities in the United States, the government, first of all, it's not a state university, it's a private university. The government and the university itself provides very little for the academician. In fact, what happens is if you become a faculty member, you have a position and you have an office. In the office, there's a plug, and there are switches for electricity and so on. Everything else you have to bring from outside. Even the paper clips that you use, the pen and pencil that you use in your research, you have to purchase yourself through the grants that you bring from other places. So I brought from the American government $100 million to Stanford over my academic life, which was 30-some years. And I ran a huge program. $100 million, as you know, is a lot of money, and I'm not exaggerating. But with that money, I was able to sustain a group of very large group of students, research staff, assistants, 2 assistants, and it was like a business, like your own business. For 30-some years, you're independent, and you're then independent of the university because you're not really getting a whole lot from the university, but you are teaching at the university, so you're interacting with the students, and you are also benefiting from the excellent PhD students that come to Stanford that then work for you. And the PhD students are drivers, really, of research and development in the final analysis. So this is very important. In any case, so with this $100 million, my group established observation sites all around the planet, on all 7 continents. I, for example, myself, went to Antarctica 9 or 10 times. I have crossed the Magellan Straits with a ship taking off from Chile and going for 4.5 days in an extremely turbulent water. The height of the waves are 16 meters. So they lose the horizon completely and you get it back completely. It's one of the most treacherous places in the planet. It takes 4.5 days to reach Antarctica. And in Antarctica, we do observations of atmospheric waves, electromagnetic waves coming from space that in some cases can only be observed in Antarctica. And I also went to Antarctica from New Zealand with an airplane that takes off with wheels and then lands on skis in the snow-covered Antarctic continent, and then from there takes off again on skis and lands at the South Pole. So I have been to South Pole 3 times in summer in the south, which is December and January. And it's really a fascinating place because the sun rotates on the top. It doesn't set, of course, rotates like this during the day, and eventually rotates on a larger circle, larger and larger, and eventually sets for 6 months, and then it comes back from the sky. So it's a really interesting place, and the height of the snow in Antarctica at the South Pole is 3,000 meters. So it's very, very high. Okay. So from the continental base, the height of the snow is enormous. So you're suddenly at 3,000 meters when you go there with an airplane, because the airplane takes off from sea level on the coast of Antarctica, and then it lands at South Pole. When you get out of the airplane, it's now minus 30 degrees centigrade, and the pressure is very low because of the 3,000 meters, so you have a very hard time breathing. Anyway, okay, so in this environment, I was working happily at Stanford when Koch University, how many of you know about Koch University? Okay, 2. Yeah, so Koch University is a university that is 29 years old, and it's one of those foundation universities in Turkey. In Turkey, by constitutional decree, you can only have 2 kinds of universities. The state can establish universities, and foundations, non-profit foundations, can establish universities. No other entity can establish university, and no other entity can provide education to university-age students. Okay? So Koç University was the 2nd foundation university established in Turkey. And foundation universities have to have a funding scheme where they are not supported by the government, but they are supported by a foundation. And the Constitution says that the river of resources should flow from the university to the students, and not an inch should come back. So you cannot make profit. In fact, you have to lose money. You have to be investing money. So Koç University is one of those, it's the best example of a foundation university, which every year invests $20 million to the students, basically. So Koç University came to me and said, oh, would you like to be the president of this university? So I didn't know much about Koç University at the time because I'm at Stanford and I'm just looking at space and so on. So I investigated this over the internet and got excited about possibly providing an important service to my home country, bringing my experiences from Stanford. And I came and talked to the people who established the university. And I wanted to hear from them that I would be able to be independent, that I would not be working for a boss, and that I would be able to take my experience and apply it to the university and fly it in the directions that I would like to fly it. So when I was convinced that this was going to be the case, I basically dropped my tenured position at Stanford and came here. This was in 2009. So then I served for 3 4-year terms as president. I'm now the advisor to the Board of Trustees. My last 4-year term ended in September 2021. Our next president is going to start next June. So we are now in an interim period. But Koç University, of course, with my experience in R&D, really did huge strides in the last 12 years, 13 years. So it's now by far the best university in the country in terms of international rankings, national rankings, and such. It's a research university. And because it's a research university, we are very interested in the basic sciences. We are very interested in the R of R&D. So I want to tell you a little bit about R of R&D. Because research and development are two different things. Development, you see, is the pursuit of the known unknown. A company may be developing a product, for example, and in developing that product, they may have some questions in mind. In other words, and the answers to which they don't know. But these are known questions. They are known. When you pursue a known unknown, you can have economic development, but you can't have discoveries. You cannot discover something new. Discovery can only come from the pursuit of unknown unknowns. This is very interesting because you have to not know what you are looking for in order for what you find to be really a discovery. Otherwise, you know what you are looking for, so you're just making progress along the lines of this development, basically. So when companies, and this is a difficult thing because in a place like Turkey, the culture is totally different. So a company has basically a set of unknowns in their minds. They're working on some products, they have unknowns, they come to the university and they say, well, I have this list of unknowns. Do you have some list of experiences and expertise that you can match with these unknowns? So can your faculty members help me? Yes, they can. Of course, we can. Our faculty members can go in there and in 1 second solve their problem and answer, find the answer for the known unknown. But this is not new. It's not a discovery. You would never get an apple out of that. You would never get anything like the most successful companies in the world or the products, you see. So the question is, how do you really pursue the unknown unknown? This is very interesting. And it applies in every stage of university life, research life, bureaucracy, everything. So let me tell you in a context of a simple example. For example, let's say I'm at Stanford and I'm writing a proposal to the National Science Foundation, okay? National Science Foundation, which is a foundation in the United States, a government entity that provides money for research. So in order to write this proposal to the foundation, I have to obey their requirements of having 15 pages. You have to have an introduction. You have to have some questions in your mind. List your questions. Talk about the importance of your research. And then put some task statements and a budget. So that some referee somewhere can evaluate this proposal and say, oh yeah, this is worthwhile doing. So why don't you just invest in this, and the government entity can then fund that. This research will be for 3 years. Typically, it may also be 5 years, but it's 3 years. So normally, what happens is you write this proposal for 3 years, and normally a person who is not too conscious about the pursuit of the unknown unknown what he or she would do is would then, oh yeah, here's my money. So he or she would then start from the proposal and write a plan to follow exactly what he said in the proposal. And in doing so, he would not, or she would not really discover a whole lot of new things. What I used to do at Stanford, as soon as I get the funding from the foundation or the Office of Naval Research or whatever, I throw that proposal away and I hire students and I'm just working on things that I'm interested in. I'm not working on what I told them I would be working on. I'm working on things that are interesting that I will be publishing in the best journals and successfully and you know, have an impact. So the next 3 years later, you are now going to write to that foundation to get more money, right? So the mundane way of doing this would be to say, oh, 3 years ago I told you I would do these things. Here's what I did. I did exactly what I said I would do, okay? And like a workman. This is a workman-like reporting of, oh yeah, I said I would do this, and I did those. So then now I want to do this, okay? So that really, that establishes nothing. It's just, the wheel is just turning on it by itself, okay? So, because what I used to do is, I didn't talk about the old proposal at all. I just talked about the new results. In my next proposal, I talk about the new results and how exciting they are and where they are published and what's happening. Okay? I forget about the fact that, because if 3 years later, what I said 3 years ago was still relevant, that's not new, you see. That's not basic science anymore. That is a known unknown. So what you need to do is the unknown. So very interestingly, in the United States, people are extremely conscious about that in a place like Silicon Valley, not everywhere in the United States. So for example, what Intel does, Intel comes to Stanford and says, we give you $2 million, okay? And I'm not telling you what to work on. If you go to a company in Turkey and if you ask for $2 million, they say, well, what are you going to do? You tell me the task statements, bang, bang, bang, dates, everything will be planned. You see, it's like a work. You see, it's not research. But Intel comes in and says, okay, just take this $2 million and do seed research. I just want to be there when the research happens. I want to be rubbing elbows with you. And if something comes out that is really discovery-like, I'd like to share the patent. Or I would like to not even share the patent. I want to just have the first right of refusal on the patent. First right of refusal. So interesting. So then what Stanford does is takes this $2 million and they announce an opportunity. They say, oh, there's a research opportunity. No topic. There's not a topic. It's to seed research in other areas. So the bright students and faculty at Stanford apply with 1 or 2 page proposals with ideas. Okay? Now the ideas are coming from the people who don't have an agenda. You see? Now the new ideas are coming from them. So whatever you find in those will be the unknown, because it will not be the agenda of some company, of some institution or something, you see? And then 12, 13, 14 proposals come in, and Stanford picks 2 or 3, and they work. And by the way, these types of things, 9 out of 10 just produces theses that you put on the shelves. Not a spectacular result, just theses, but one makes you fly, you see. It's that one that you should look for. To get that one, you have to create an environment of free intercourse, a free discussion, among people and free choice of topic, and let them be. Then things that you don't have in mind happen. Then things happen that are new, you see. This is very, very, very interesting. So how does a university like Koç University pursue research and basic research? Not by listing topics and by hiring faculty to those topics. You simply go out, establish a great institution, hire faculty, whatever topic they're in, hire them, and then get out of their way. You let them be free. You let them do whatever they want and provide support. And then 9 out of 10 of those would do great work. Great theses will be a reputation, will come to the university and so on. One of them will fly. This is the interesting part about this. You see, it's the pursuit of the unknown. In places, in countries like most of you are from, and in this country, a lot of times governments actually spend a lot of money on research, but they spend this money with so many strings on it that the recipient of the support is shackled. The recipient cannot think free, and the recipient is just trying to do what he or she said he or she would do 5 months ago or 6 months ago. That's not any more relevant, you see. So if that happens, then the money is just going down the drain. This is very interesting. The bureaucracy in places like Turkey is set in order to shackle the many because of the few. You do not penalize the many because of the few. The whole system is set up so that few abuses don't happen. In order to prevent the few abuses, you bring so many restrictions and regulations, so many pages, so many things to be written down, that the many are penalized. What you should never do is to penalize the many because of the few. What you must really do is liberate the many in spite of the few. Okay? You have to recognize that the few abuses will happen. You have to create the easiest and the freest environment for the bright brains to pursue the best ideas that they have, not the ideas that you have given to them, but what they have. So I told you I graduated 60 PhD students. I didn't define the PhD thesis of any one of them. They defined it. Although, of course, it's in the, I mean, they couldn't study the oceans because I'm studying space science, but in the general context of the topics that we are interested in, they picked their own PhDs because if a person picks his or her interest, him or herself, then they would fly. You don't have to do anything. Then they are working 24/7. And in fact, they are more interested than you are now. They are not working for you now, they are working for themselves. And because they are working for themselves, you're getting the most outcome, and everything is just flying high. This is very, very interesting. So I think in pursuing basic research, I mean, what I did in my PhD thesis at Stanford was a very theoretical estimation of what happens between electromagnetic waves and high-energy electrons in near-Earth space. At that time, it didn't have any application. But 35 years later, there was a satellite, $300 million satellite, that was built specifically to investigate that topic. And it was driven by that basic scientific work 35 years ago, and it investigated critical things about the radiation belts of this planet that are very important for satellites in space, for example. So everything is like this. Scholarship is very important. When you do research, I'm not sure whether you guys are not PhD students, right? Is there any PhD student here? Oh, yeah, okay, right. Okay, I didn't know. So, whatever you study in your PhD, the most important thing you can do is to go back as far as possible and read old papers. Because somewhere 30 years ago, 40 years ago, there's a paper that probably has been buried and staying dormant that can be extremely relevant to what you are doing. This is called scholarship. Scholarship is the awareness about past work in your own field. Full, complete awareness, not just superficial reading of the abstracts. This is what you are supposed to do to advance knowledge on top of old knowledge. But the other thing about this unknown unknown and known unknown business is the topic of something called serendipity. How many of you know what serendipity means? Serendipity. S-E-R-E-N-D-I-P-I-T-Y. Serendipity. Serendipity. D-I-P-I-T-Y. So this is an English word, but it has entered the English language in 1780 or something. English language is pretty old. It's like 2,000 years. So 1760 is quite late, right? So serendipity, it comes from a sequence of storybooks, children's storybooks, written in India. Some old guy in India wrote children's books. And these were Prince Serendip's adventures. The prince's name was Serendip. That's why it's called Serendipity. And the gist of these books was that this was a children's book, right? The prince goes into the forest looking for something, whatever. He's looking for something. And he always finds something else, much more interesting than what he was looking for. Okay? He's looking for something else, but he finds the really important. That's what serendipity is. So serendipity should be allowed and kept in mind in the pursuit of basic sciences and academic life and research, because that's where the real discovery lies. I mean, that's how you can find the unknown. That's how you will, if you're looking for something, you already know a lot about that something. So it's not going to be earth-shaking. But if you accidentally find it, then it's almost certain to be earth-shaking. That's very, very important. Serendipity. So remember serendipity. You can. Some of you are looking it up. It's up there, right? It's in Google. You found it. Oh, did you find it? No. No. S-E-R-E-N. No. It's very correct. Okay. Should I erase this important theorem? Should I erase it? I mean, it's Pythagoras theorem, so most of you know it anyway.
Its definition, it says the occurrence and development of events by chance in a happy or beneficial way.
Mm-hmm. Yeah.
Serendipity, yeah.
Yes, serendipity, yeah. It's
No, the occurrence and the development.
Yeah, it's coincidence is a simple way of looking at it. It's not coincidence. It's an accidental discovery of something when you are looking for something else. It's an accidental, unexpected discovery of something when you are looking for something else.
This is a moment, while the serendipity is a group of moments, let's say, yeah? It happens continuously.
No, this is one word.
Yeah.
One word, yeah. But this part was the name of the prince who was writing the books. But anyway, it's the point of this whole discussion really is that in basic science has to be the pursuit of the unknown. And basic science has to be done and driven by curiosity. You see, this is a discussion that governments everywhere struggle with. Because if a government is going to provide $1 billion for research, are they going to provide this money for an applied research in already defined areas, or provide a substantial part of it also in curiosity-driven research, you see? This is very important discussion in the United States, in Europe, in Turkey. In Europe, they don't understand this serendipity. In Europe, they are much more along the lines of defined science. So European Commission, for example, sets priorities. These are the priorities. In listing a priority list of 5 topics, you are eliminating everything else but those 5 topics. You are eliminating discovery. So you see, the basic science and the serendipitous discovery is buried. This is a danger. And companies, unfortunately, always fall into this trap. Because the company is always looking at the bottom line at the end of the year. So the CEO of the company is going to reserve some money for R&D. And the R&D money that he reserves in his budget will be for the short term. But short term is not where serendipity is going to happen. The unknowns are going to come from a carefully constructed long-term and mid-term research plan that involves freedom for the researcher. The researcher has to be completely free. So we create this environment at Koç University. We don't let the faculty members, we don't force them to work on some topics. They choose their own topics. And they can be long-term and so on. So this is, unfortunately, of course, in Turkey, because it's much more a regulation-driven country, a bureaucratic country that comes even from the Ottoman times. But Europe also, extremely bureaucratically driven. Everything has to be written down. The more things you write down, the more you are shackled. For example, we never make a 5-year plan at Koç University. Because if you make a 5-year plan, you're then the prisoner of your 5-year plan. 2 years into the 5-year plan, there could be new things. Now you need to change the plan. It's really, it's not the right thing to do. But the Europeans work with a 5-year plan, written down. If it's not in the plan, it's not even allowed, okay? So then all the new ideas, curiosity-driven ideas, have a much higher steep hill to climb. Curiosity-driven research. Individuals are born with mental abilities that have a huge dynamic range, okay? I mean, some people are here, some people are here in terms of their ability to see the future, their ability to discover. So the society has to enable those that are the most curious to discover those things that would change the society. And to do that, you need to free them. You need to liberate them from all kinds of bureaucratic shackles. I say this as if I'm a prophet, but then it's very difficult to do. Of course, the whole society has to be geared in this way because the tendency is always to check. You said you were going to do this. Did you, in fact, do this? 3 years later, they're asking you. TÜBİTAK, for example, is asking us, okay, so I wrote a proposal. I said I'm going to do this. And now, 3 years later, I may have done something much more exciting, but I need to tell TÜBİTAK whether or not I did what I said I was going to do. It's very interesting. Unfortunately, a lot of people may abuse the system. So to prevent abuse, you have to follow through. But in following through, you are extinguishing the flame of curiosity. This is very interesting. So keep this in mind, and you know, always try to ask questions. So, for example, this is interesting. The more you know, the less you can ask questions. This is very interesting. So I had 20 students in my group. I graduated 60. So at any given time, I had 20 PhD students. None of them had GPA over 4.0 of less than 3.85. They were brightest of the brightest. They're Stanford students, okay? So now they're doing research in their topics. They're doing their theses. I also had undergraduate students who know much less, right? So I have these undergraduate students in the summer working with the graduate students. So we have a seminar. So the graduate student gets up and describes something on the board. He has provided slides and so on. And he's showing something, and everyone is following. The undergraduate, one of the undergraduates, because he doesn't know, he says, or she, or often it's she, but she says, well, why are you doing it this way? And the graduate student says, well, because we have been doing that way for some time. He doesn't really know why he's doing it that way, you see? And he can't even ask the question because he knows that that's the way you should do it. But in the question of the undergraduate, that is asked from the point of curiosity and naiveness, lies a discovery. At least a few times, I've seen papers written because of the question that the undergraduate asked, because he knows not as much. So this is interesting because in some cultures, high school and university education is very intense. It's very, very intense. I mean, knowledge is crammed down the throat of the students. They know everything. I mean, they have taken math 1, 2, 3, 4, 5, 6. They know everything, okay? But because they know everything, they now can't think in a discovery way, you see, because they can't even ask questions. So this is interesting because because it's space science, my work because it's space science, at Stanford, by far most of my students were American people. In other words, they weren't Chinese or Indian students and so on. And these people were from like University of Kansas or Cornell, places like that, where the education is not unbelievably intense, like it is in some of them. In my university, at Middle East Technical University, I took everything. I mean, I had so many classes. In electromagnetics theory, I took 1, 2, 3, 4. Advanced 1, advanced 2. I took all. Okay? But these American students who didn't know as much, but were curious and bright, they were able to do a lot more of discovery. That's one reason why patents, by far, are much larger in the United States than elsewhere. So it's interesting. You should also not know too much. You should go back and know the literature, but you can't be buried by that knowledge. You have to also be, every time you look at something, you have to be able to have the courage and self-confidence to question. Say, why? Why is it being done this way? Anyway, so Let me see, what else? There's a question-answer session too, right? Gülizar Hanım.